Do you guys know what are the different types of circuit elements that is there? If you ask this question to an engineer or even a passive student, they will say resistor, inductor, capacitance. That is not a right answer, guys. So that all are some definition that is not absolutely wrong. But the thing is that the main thing what the guy will, if the core companies or any guys will be asking this question, what they will expect us to answer is this one: the active, passive, linear, non-linear. So these are some types of circuit elements. There are 10 different types of elements, guys. So as the follows: 5 pass and 10 different things is there. So before that, let us solve the previous one homework. So please, I think everybody has solved this one. So if you guys haven't solved it, so please make note of it now. I think plenty of guys are able to solve it. So let us make the notes. This one is A, so this one is B, and this one is C. So you see there is only 3 notes. So 3 notes, and how many branches is there? Is that 1, 2, 3, 4, 5. So 5 branches are there. So the mesh can be calculated as 5 minus 3 plus 1. So there is 3 mesh. Okay. So 3 mesh is this one, this one, this one. So if you can calculate this loop here, so there is already, let me try to calculate it. So there is already 3 mesh. So this one come as a fourth one. So this one come as fifth. So this one come as sixth. This one come as seventh. So for now I can calculate 7 and the last entire loop, that is 8. So 8 loops are there. I think that's it. If you guys able to find out any other loops, please make note of it. I think only 8 loops is there. It will be quite confusing. That's why I haven't asked loops for you guys to find out. I think 8. So if you guys find out any other loops other than this one, please name out that. I will be appreciating you with that answer. Okay. So let us now get into the types of elements, a circuit element that is generally there. So there is a 10 types, guys. So there is an active, passive, linear, non-linear, bilateral, unilateral, distributed, time variant, and time invariant. So these are plenty of good type things. I'm pretty sure that you guys may know all these namings, but now I let me explain everything detailing so that you guys will have the context of this. So once you guys learned all these 10 parts, then detox will be quite easier for you guys. So now first let's take the active and passive. So what do you mean by active and what do you mean passive? So even in the active and passive, there is many things. So like independent sources and dependent sources. So many things is there. So first let me talk about independent sources. So independent source and dependent source. So source is nothing but maybe voltage or current, anything. So that is why we will be stating that. So in independent source, there is an ideal and practical. There is in that there will be two. So that is ideal source and there will be practical source. That will be practical. So practical source is nothing but there will be some resistance, internal resistance and internal current draining element will be there. So that is one thing. There will ideal voltage and ideal current element. So that is so these are some 4 pairs here. So in dependent source we have VC VS means voltage control voltage source, current control current source, and then voltage control current source, current control voltage source. So these are some quite different thing. I will name everything, so please hold for it. So in passive, what are the thing is that there will be R, there will be L, and RBC. So these are the 3 elements that will be there. So in between, in this also there will be linear and non-linear. So that is some quite differences there. So linear and non-linear are okay. So in this also linear, non-linear. So linear, non-linear. So here also linear capacitance, non-linear capacitance are there. Okay, so these are some pretty much good variation between the things. If you see, it will have two. So it will have two. It has 4. Okay, okay, it has 4. So this is the difference between this has 2. So this is the difference between active and the passive thing. So let us now deep dive into each thing. So first let us take the active element. So in the that is what the blue chart. I know. I think you guys able to get all the thing. So let us deeply discuss what you mean by active elements. So elements that are capable of delivering the electrical energy. So delivering electrical energy. If you see the voltage source and current source, which will be capable of delivering something. So that is what we call them as active elements. So consistently or for an indefinite period of time are called active elements. So element capable of amplifying a signals are also called as the active elements, like BJT, MOSFET, op amp, battery, generator. These things can also be called as the active element. So if we take the examples, our known example is that BJT, MOSFET, everything. So if you guys didn't know what you mean by BJT, MOSFET, I have already took the lecture on the semiconductor physics under the electronic devices and circuit. Please go and watch things. So op amp, even what if battery. So these all are some kind of active elements. Okay. So what you mean by passive elements is that, so passive elements. So the element that absorbs the electrical energy. The elements that absorbs the electrical energy. So these are all generally called as the passive elements. So the known passive elements are resistor, capacitor, inductor. Other things also the transformer, diode, and a TCR. Those things also there. But let me know the known example, that is RLC. Okay, so this is a known passive element, right? So now let us discuss the VI characteristics of the active and the passive element, so that you guys will be coming to know more on the things. So let me go to the VI characteristic curve. So here everything guys, so whenever there is a graph or diagram is coming, then you guys need to think that we are going to understand more there. So instead of learning generally with the theories, so the practical things will give more understanding there. So here if you see the VI characteristics of the passive and active elements. Okay, so now let me draw the generalized curve and then I will explain that with each them. So let us take the VI characteristic curve that we already know. I think if you guys already watched my EDC lecture, you guys will know. So I is in x-axis and V is in y-axis. So if we think here the slope will be positive, both will be positive side, right? So here the slope will be positive. Here this will be negative. So here the slope, even if one term is negative, then the slope is considered as negative. So when slope is positive, that term will be considered as passive element. When the slope is negative, so here also it will be negative. So this will be considered as a active element. So this will be considered as active element. So here both are negative, so this will also be considered as passive element. So here if you see, if any of the elements characteristic curve that lies in this four quadrant, based upon the quadrants where it is lying, we can consider this element to be active or passive. I will explain it clearly, don't worry. So if R is less than 0, then P will also be less than 0, then delivered active element. So power is delivered, then that will be considered as active element. If only graph between V and character is specified, then if slope is positive, then that will be a positive element, sorry, passive element. The slope is less than 0, then that will be called as active element. The slope of the VI curve represents resistance. So we already know that. So the slope of the VI element is directly proportional to resistance. The slope will be directly proportional to resistance. That will be 1 by resistance. But that is not our problem. So whenever R is less than 0, which we clearly indicate that P is less than 0, which means that it is delivered, means power is delivered. So means that will be active element. Because in passive element, the resistance can't be less than 0, right? So if resistance is greater than 0, then power is observed and that will be passive element. Okay, so that is what the quiet analogy we are going to find out whether the particular element is active or not. Okay, so this is method 1. So method 2 is that if voltage polarity, current direction as well as is given, then if the current enters the positive terminal, we know that power is observed. So that is previous class we discussed, right? So from there we can do, but this will be fine. So let me let me give you some examples so that you guys can understand it. So let me take an analogy and then I will explain with the VI characteristic curve also. So here let us take the thing. So this is the current carrying element. So let me connect the current source to this. Okay. So here if you see, so here this is the current carrying wire. So if we take the reference, Let me draw the VA characteristics also so that you guys can able to understand it clearly. Okay, so this is what the VA characteristic. So let me name this element to be Z, and this is the I, and this is V. So let me copy this to all the pages so that it will be very easy for me to write. So let me use this one. Okay. So thing is that we are going to consider that the positive voltage is applied here, plus, negative, and V, and current is entering over the positive terminal. So if it is like this, we clearly know that this is power is going to be absorbed by the element, because here if you see, the power is leaving from entering over the positive terminal. This we already discussed, right? So power is going to be absorbed, and the VA characteristic, how this VA characteristic will be is that it will be generally like this. It will be tracing like this way. So here if you see, here also the slope will be positive. So here also P will be greater than 0. Here also power will be greater than 0. If it is lies in both this element, then we can clearly call this element to be passive element. Okay, I hope you guys able to get you guys getting my point, right? Okay, so even if even if this analogy you didn't know, from the graph also we can stay. If the V characteristic is lying in the this quadrant, this is first quadrant, this is second quadrant, third quadrant, fourth quadrant, right? So if it is lying in the 1 and 3, then we can clearly state that it will be the passive element. So here if you see, the V characteristic is lying only in the 1 and third quadrant, means it is a passive element. So if current enters positive element, we can also use the slope criteria. Okay, so that is what I think. So now let us take another one analogy. So this is the, let us take the different element now. Okay, so here let us take the same positive, negative, the same voltage applied. The current is also entering over the positive terminal. But here what happens is that the voltage curve is given like the VA characteristic curve is given like this. Then this means what? The current enter from this analogy we know that the P is absorbed. So P is going to be absorbed by this element. So if P is going to be observed from this graph, but in the VA characteristic, what we say, we can see clearly state that P over power is less than 0, because this will be, the slope will be what? Slope will be negative. So V will be less than 0, the I will be greater than 0 here. So the power will be less than. So here V will be greater than 0 and I will be less than 0, means power here also less than 0. Since I enters the positive terminal, the slope criteria can be applied. But slope is less than 0. So means here the slope is less than 0 and also it is lying in the second and fourth quadrant. Then this element will be called as the active element. Okay. So that is what the difference case. So based upon the presence of VA characteristic, we could clearly state that it will be there. So here if you see, the power need to be observed, but here if you see, the power is less than 0, means that it is delivered. So if it is delivered, then that will be called as the active element. So that is what the relation. Okay, so let us take another one quite more example so that you guys can able to understand more here. So this one I am going to give this to you, so please pause the video and try to answer it. So we are taking the same reference, positive, negative voltage, and current is entering in this direction, and our slope is coming like this way. So it is tracing the curve, it is initially at 0, after reaching here it is going this way. Okay, then what will be the thing? So please pause the video and try to answer it. I'm sure you guys can able to achieve it. So here if you see, current is entering positive terminal, the slope condition can be applied. So here if you see, the slope is 0. So here if you see, the slope is greater than 0, means what? That the element is not, the slope is not less than 0. It once it is 0 or it is greater than 0. So means this element will be passive. Okay guys, if you guys able to achieve it, then I am very proud of you guys. So let me give you one more thing. So please pause the video and try to answer for this one also. Please comment the answer. Once you guys able to get it, please post in the comment section also, so that I will be able to get notified and I will be thinking that you guys able to understand the things. Okay. So here slope is coming like this and then slope is going like this. So here if you see, please pause the video and try to answer it. Here the slope is less than 0. Here the slope is greater than 0. So even one time the slope is less than 0, this element will be considered as active. Okay, so this will be active element. Okay, so let me give the last example. So once you guys able to achieve it, you guys will be able to understand the things more. Let me use the same example. So the same voltage source, positive, negative, and current is entering in this direction. Okay, so this is tracing in the negative axis first, third quadrant first, and then it is tracing the boundary. Now what will be the element? Please pause the video and try to answer it. So here we know the slope is greater than 0. So here we know the slope is equal to 0. Every time the slope is greater than or equal to 0, so this element will be called as a passive element. Okay. So now you guys able to achieve more things. I'm pretty sure that you guys can answer plenty of the question. So I am very happy to say that you guys are now well versed to find out whether the element is passive or active with the help of VA characteristic curve. Okay guys. So from here I am stopping this lecture. So this would be very much good information for you guys to understand more thing. So next class we can discuss more thing on this. So next class I will be starting with the time variant and invariant element. So similar to your signals and systems only, that I will explain very neatly. So please pause the video and try to answer it if you guys have been getting anything. So I hope you guys getting some good information with my lecture. Please like, share and subscribe the channel so that I'll be getting motivated to post more videos like this. Thank you guys. Stay tuned, stay motivated, learn and crack the gate and get into IITs and also get into many of the core companies as per your dream offer. And this will also be helpful for you guys to clear examination, college examinations also. So everything is covered in one thing. So that's why I thought to continue this one. So thank you guys. Stay motivated and motivate me also. Thank you guys. Stay tuned.